Hello, class, and welcome to our discussion today. In our today's discussion, we are going to look at the tree diagram. As far as probability is concerned, a tree diagram is actually a pictorial presentation of events and their probabilities. From our discussion, we said an event is actually are the outcomes from an experiment. So when we have an experiment that has been conducted, we are going to have different outcomes that we are going to witness from that particular experiment. The way we are going to draw that particular experiment and all the possible outcomes in a picture way is actually what we mean by the tree diagram. Let us have an example. Maybe a coin is tossed three times. A coin is tossed three times. And now you are told, can you draw a tree diagram to show all the possible outcomes and their probabilities? So we are going to have it this way. We are going to start with the first actually experiment. When we are drawing it for the first time, we are going to have the two possible outcomes. That is either head or tail, and remember the probability for each is half half. That is the first tossing. When we toss twice, the second time, that is either head or tail is going to show up. Again, the probability is half half. That is the case where the first outcome was actually the head. What about if the first outcome was tail? The second outcomes can either be head, which is half, or tail, the probability, which is half. Remember, this part here presents the second tossing. Remember here, represents the first tossing. So when we toss it first, either head or tail will show up, and the probability is half half. When we have head as the outcome for the first tossing, the second tossing, again, we are going to either witness head or tail. So we draw another branch there with the probabilities of half half. If the first outcome was tail, the second outcomes can either be head or tail. That's why we have this. Then now we proceed to the branch number 3, which is now for the third tossing. The outcome can either be head or tail, and the probabilities don't change. It is half half. If the second tossing was a tail, given that the first one was head, the probability for the third can either be head or tail, which is actually half half. If the first one was tail, the second one is head, the third one can also be head or tail, and the probability is half half. If the first one was tail, the second one was tail, the third one can either be head or tail with the probabilities half half like that. So in this case, we have got the probabilities head, 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 the outcomes, that is the head, head, head. So we have head, head, head. Here we have head, head, tail. So this is head, head, tail. This represents head, tail, head. This represents head, tail, tail. This represents tail, head, head. This represents tail, head, tail. This represents tail, tail, head. This represents tail, tail, tail. Like that. That is actually the tree diagram with all the possible outcomes and their probability. Using this tree diagram, you can be asked to find the probability that all the three are heads. That is head, head, head. What is the probability that we are going to have heads all through? So it is head, head, tail. So you just come here. The head here is half, half, half. So you multiply the probability of being head times the second one being head times the third one being head. So you find this one is going to be 1 over 8. You can be asked, what is the probability that all the three outcomes are going to be tail? So that is the probability for tail, 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 which is going to be a half times a half times a half, which is actually going to be 1 over 8 again. You can be asked, what is the probability that the first two outcomes are heads? So the probability of first two are heads, you just go to where we have at least two heads starting. At least two heads starting. So it's actually this combination and this combination, because we have got two heads that are starting as the outcome. So in this case, it is the same as probability of head, 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 or probability of head, head, tail, like that. So you'll come here and do 1 over 2 times 1 over 2 times 1 over 2. That is all heads here. Or simply means we do the addition according to the law of probability. And here it is head, head, tail, which will also be 1 over 2 times 1 over 2 times 1 over 2. That is head, head, tail, head, head, tail, this combination here. So it's going to be 1 over 8 plus 1 over 8, which is going to be 2 over 8, which is actually going to be 1 over 4. That is actually the answer. So having obtained the tree diagram, it becomes very easy for you to be able to calculate that. So I want us to look at another example. The example I want us to do is what you have in your notes, which talks about the probability that Omweri will go to Nakuru. You are told that the probability that Omweri goes to Nakuru is a quarter. So here we need to draw a tree diagram to represent that he goes, and here he goes not. The probability of going is a quarter, meaning that the probability of not going is 3/4. So going and not going, G with apostrophe means not going, is a quarter. Then you are told, if he goes to Nakuru, the probability that he will see flamingo is a half. If he goes to Nakuru, the probability of seeing flamingo is a half, meaning that the probability of not seeing the flamingo is also a half. I want to emphasize this part here. The probability of something happening plus the probability of the same event not happening, they must add up to 1. So if you are given the probability of going is half, the probability of not going is 1 minus a quarter. Sorry, the probability of going is a quarter. The probability of not going would be 1 minus a quarter, which is 3/4. If you are given the probability that he will see flamingo is a half, the probability that he is not going to see flamingo is 1 minus a half, which is a half. Then you are told this. If he does not go to Nakuru, remember, if he does not go to Nakuru is here, the probability that he will see a flamingo is a third. You will see a flamingo here is a third, meaning that the probability of not seeing the flamingo is going to be, the probability of not seeing the flamingo is going to be 1 minus a third, which is 2/3, which is not seeing the flamingo. Now you are told this. Using a tree diagram, find the probability that Omweri will go to Nakuru and see the flamingo. So it is going to Nakuru and seeing the flamingo. This is going and seeing the flamingo. This is going and not seeing the flamingo. This is not going, but he sees the flamingo. This is not going and not seeing the flamingo. So for part A, Omweri will go to Nakuru and see a flamingo. It is going and seeing the flamingo, going and seeing flamingo. would be this branch going and seeing, which is now going to be a quarter times a half. Like that. Part B, Omweri will not go to Nakuru, yet he will see a flamingo. Not going but seeing the flamingo is going to be 3 over 4 times 1 over 3, which is going to be 1 over 4. Roban 3, Omweri will see a flamingo. Omweri will see a flamingo is actually going to be of two options, either going to Nakuru and seeing, or not going to Nakuru and seeing the flamingo. The probability of seeing flamingo would be equal to going and seeing the flamingo, or going not and seeing the flamingo. In this case, it's going to be either a quarter times a half. Anywhere we have or we use the addition. Not going is 3 over 4, but seeing the flamingo 1 over 3, like that. So this one is going to be 1 over 8 plus 1 over 4, which is going to be 8. 8 divided by 8 is 1. 8 divided by 4 is 2, which is going to be 3 over 8. That is going to be the probability. So if you are able to draw the probability tree diagram, solving the equations becomes very easy when you use this approach. Thank you very much.